The World Cup recently finished and Spain won. I didn't watch very many of the games. In fact, the last one I watched was the England-Germany game when England got trashed. But a lot of people were making comments about these trumpets that were being blown throughout the games. I think they're called Vuvuzela, these long plastic trumpets that all make this same note. And certainly during the England-Germany game, all the way through the match, there was just this constant background sound of these trumpets being blown, thousands and thousands of them, you know, because the crowd, seemed like everybody in the crowd had one. It was quite interesting in a way. It was distracting at the same time, but it was quite interesting because there was this background noise the whole time. Sometimes it would go up in volume a bit, and sometimes it would go down, but generally it was very, very level. Which meant that just there were so many people, because obviously individual people were taking breaths or putting theirs down for a bit, or taking a break, or having it snatched out of them by some irate passerby or whatever. But the fact there were so many of them doing this meant that the sound was constant, a constant drone in the background. Except for one or two specific times. I can't remember if it correlated with goals being scored, a particular event in the match itself, possibly. But occasionally these vuvuzelas, or the people who were playing these vuvuzelas, would kind of hit a rhythm, you know what I mean? So instead of this being a constant, it would go like that for a while, and then it would just kind of break up and dissolve back into this drone sound. And I guess just all that's happening there is some guy starts doing it, and then the two or three people around him join in, and so it makes it louder, and then people, you know, within a few meters of that person can hear the rhythm and join in that rhythm until it's loud enough that pretty much everybody in the stadium can hear it and join in, so the whole stadium kind of pulses with this sound. And then, as I say, one person stops and another person stops, and it goes back to the background again. I mean, what that serves as for me is a kind of image of neuronal fire. I've used stadiums as images for brains before, actually, it's what I keep coming back to. But again, it's just like this image of what a neuron is like, what a part of a brain is like. Because neurons, you know, those the brain cells, they've got whatever it is, between 10 and 40,000 inputs, different dendrites coming into them from other neurons. And the one single axon going out, so lots and lots of input signals and one output signal. And when those input signals get together in a certain way and reach some kind of threshold, when they all fire at once basically, then that's the signal for the neuron itself to be activated, and it sends a signal out through its axon. But when they're all firing individually, all these different dendrites that are coming in are not synchronized, when it's just, you know, lots and lots of firing but completely sporadically and completely out of sync, then the neuron doesn't fire. They need to be synced for the firing to take place. So it's a little bit, for me at least, like these vuvuzelas in the World Cup stadium in South Africa. You know, as long as they're just all firing asynchronously, they're just firing at random, and it's just this background sound, this background drone. In actual fact, you don't even hear it. I mean, I stopped hearing it after a while. It's only when they synchronize, when they're organized gaps, if you like, in the firing, and organized, it becomes distinguishable as a rhythm or as a set of sounds and silences. Then you notice it, and it's almost like the axon has fired. You know, the stadium itself, the sound from the stadium itself has been, has fired a signal out from itself, out from its axon. It's just a visual image I use to think about these things, really. I mean, if you're going to model the brain would be whatever it is, 10 billion football stadiums, because each of those football stadiums is a neuron. So what you would need is, if you're going to brain model it, you would need whatever it is, 10 billion football stadia, each of those containing between 10 and 40,000 people playing vuvuzelas, and each of those stadia interconnected in rather complex ways. God, yeah, because each stadium would have to be connected up to an individual Vavazoo in a different stadium, wouldn't it? Because the axon that leaves one neuron becomes the dendrite going, one of the 10 to 40,000 dendrites going into another neuron. So you would have to have, you'd have to have some kind of microphone from from each stadium leading to a Vavazoo in another stadium, which would only sound when, oh God, when the Vavazoos in Stadium 1 were synchronized. That's an image you're never going to get, is it? Oh well, I'll keep thinking about it.